Did you know that one mistake could cost millions of lives? In this story, the USA decided the fate of the war in just a few days. If you're interested in the truth about World War II, subscribe and hit the like button. There are many shocking facts ahead. September 17, 1944. Imagine yourself soaring 14,000 feet above the patchwork fields of Eindhoven, Netherlands. It is the opening day of Operation Market Garden, and the sky is about to witness the largest airborne operation the world has ever seen. Across the Dutch countryside, thousands of paratroopers prepare to descend, while above them, a storm of Allied aircraft sweeps the skies. Among them, P-47 Thunderbolts prowl like steel predators, their wings burdened with ordnance that would have seemed inconceivable only a year and a half earlier. For the Luftwaffe pilots racing to intercept, the sight is bewildering. These bulbous American fighters carry 2,500 pounds of bombs, half the payload of a B-17 Flying Fortress on a long-range mission. The aircraft they had once dismissed in 1943 as clumsy and ponderous has undergone a transformation that defies their deepest assumptions about air combat. This is no mere fighter. It is a single-seat, single-engine powerhouse capable of punching its way to a target, delivering the payload of a light bomber, and fighting its way back through enemy skies. The evolution of the P-47 from a simple interceptor into the most formidable fighter bomber in the European theater would not only alter aerial tactics, but accelerate the collapse of the Wehrmacht and redefine military aviation for generations to come. What the Luftwaffe never predicted was that American industrial pragmatism had birthed more than a fighter or a bomber. They had engineered a new class of warplane, a universal combat aircraft capable of performing any mission anywhere with lethal precision. When the Republic P-47 Thunderbolt first entered combat in April 1943, it seemed to confirm every German prejudice about American design. Large, heavy, powerful, but lacking the delicate finesse of German engineering. On April 8, 1943, when the 4th Fighter Group flew the P-47 on its inaugural combat mission, German intelligence dutifully recorded their conclusions. The numbers alone seemed damning. An empty weight of 10,000 pounds double that of a Messerschmitt Bf-109G. A monstrous Pratt & Whitney R-2800 double wasp, 18 cylinders generating 2,000 horsepower. Later variants would push 2,300 and eventually 2,800. And yet, the airframe appeared to scorn the very concept of streamlining. Early combat seemed to vindicate German skepticism. The P-47's initial combat radius of merely 125 miles made it a poor escort for bombers. Its climb rate lagged behind the nimble German fighters, and in turning battles at medium altitudes, the Focke-Wulf 190 and Bf-109 could dominate. German pilots quickly devised tactics to exploit these apparent weaknesses, forcing the heavy American into maneuvers where its mass became a liability. But the Luftwaffe had misread the story unfolding before them. They were watching the P-47 in its infancy, unaware of the potential that lay dormant within its steel-clad frame. Its formidable weight built from armor and reinforced steel tubing was not a flaw but a foundation. It allowed the aircraft to endure punishment that would have shredded most contemporaries. The wing pylons, originally conceived for fuel tanks to extend range, were engineered to bear 2,500 pounds of bombs a load that would have torn apart nearly any other fighter in existence. The P-47's transformation did not emerge from grand strategy, but from the relentless pragmatism of pilots in the field. As 1943 unfolded, returning from bomber escort missions, Thunderbolt pilots began to seize every opportunity to strafe railway locomotives, truck convoys, fuel depots, anything that could be hit. And the results were immediate and dramatic. The 8 Browning M2 50 caliber machine guns, each unleashing 800 rounds per minute, could deliver 12.7 pounds of molten lead every second, enough to rip apart a locomotive boiler or shred a convoy of trucks as though made of paper. The first formal steps to convert the P-47 into a bomber came in November 1943. Engineers mounted bomb shackles rated for 500-pound bombs beneath the fuselage and on the wings. On November 25, 1943, the 62nd Fighter Squadron flew the first official P-47 bombing mission, targeting the Luftwaffe airfield at Saint-Omer, France. 8 Thunderbolts, each armed with two 250-pound bombs, leveled 2 hangars and damaged 5 aircraft on the ground. The aircraft that had seemed cumbersome and high-altitude bound was now proving its lethal versatility. Through the winter of 1943-44, Republic Aviation and the U.S. Army Air Force Technical Services accelerated this transformation. Wing spars were reinforced to endure asymmetric loads when bombs were dropped unevenly. Electrical systems were redesigned so bomb release mechanisms could operate flawlessly at 30,000 feet or mere treetops. Gun sights became specialized instruments of destruction, including the K-14 computing gun sight, capable of calculating precise angles for dive or glide bombing. By early 1944, the P-47 was no longer a fighter merely carrying bombs. It had become a one-aircraft arsenal. The M8 4.5-inch rockets, each packing the force of a 105-millimeter artillery shell, gave a single Thunderbolt the firepower of a naval destroyer. One plane could carry 10 rockets, plus 2 1,000-pound bombs more explosive weight than many twin-engine bombers carried early in the war. D-Day, June 6, 1944, revealed the full scale of the transformation. On that single day, P-47s flew 1,185 sorties, dropping 525 tons of bombs and firing 135,000 rounds of .50 caliber ammunition. They obliterated 86 locomotives, 507 motor vehicles, 38 gun positions, and 17 fuel dumps. The aircraft the Germans had once labeled a mediocre interceptor had become the backbone of tactical air power. Even the Luftwaffe's elite aces felt the shift. Gunther Rahl, credited with 275 victories, recounted in a 1996 interview with HistoryNet, "The P-47, which, as you know, shot me down, we knew right away. It had tremendous diving speed, reaching up to 1,400 km h, while the Bf 109 and 190 topped out around 1,000. I learned this the hard way. When they chased me, I could do nothing." On May 12, 1944, Rahl was shot down by P-47s of the 56 Fighter Group, losing his left thumb in the encounter. His damaged flying glove now resides in the National Air and Space Museum. After the war, Luftwaffe instructors logged roughly 300 hours evaluating captured P-47s at their fighter leaders' school, confirming what Allied pilots already knew. The P-47's ability to transition seamlessly from bomber to fighter created an almost unsolvable tactical puzzle. German interceptors sent to punish what appeared to be vulnerable fighter bombers suddenly faced fully armed, heavily armored aircraft, capable of unleashing massive firepower and enduring punishment that would have destroyed any other plane. The numbers tell the story. A standard P-47 D-25 could carry 2 1,000-pound bombs, 3 500-pound bombs, or a combination of bombs and rockets totaling 2,500 pounds, roughly 62.5% of a B-17's typical 4,000-pound long-range payload. A squadron of 16 P-47s could, in a single sortie, drop 32,000 pounds of bombs equivalent to the load of 8 B-17s. But unlike the heavy bombers, which flew twice weekly from England, P-47s could fly 3 sorties per day from forward airfields. One squadron could, in theory, deliver more tonnage in a day than a bomber group could in a week. The efficiency was staggering. One P-47 with 2 500-pound bombs needed a single pilot and minimal ground support. One B-17 with 4,000 pounds of bombs required 10 crew and specialized maintenance. The fighter bomber offered unprecedented destructive power for a fraction of the manpower. August 1944 brought perhaps the P-47's most devastating demonstration during the Falaise Pocket operation. Between August 12th and 21st, as German forces tried to escape encirclement, P-47s attacked relentlessly from dawn to dusk, rotating squadrons to maintain unbroken pressure. Verified kills included August 13th, 112 tanks, August 14th, 287 motor vehicles, August 15th, 42 locomotives, August 16th, 89 horse-drawn vehicles. Roughly one-third of all German vehicles destroyed in the pocket fell to air attack, with P-47s accounting for the majority. By September 1944, the deployment of the 5-inch high-velocity aircraft rocket, HVAR, transformed the Thunderbolt into a tank destroyer. Each rocket, with a 60-pound warhead, could pierce the armor of even Tigers and Panthers. A single P-47 could carry 10 HVARs, unleashing the equivalent of a battalion artillery barrage in one pass. The 362nd Fighter Group pioneered these attacks, diving from 5,000 feet at a 30-degree angle and releasing rockets at 1,500 feet, achieving direct hits on 30 to 40% of launches, accuracy far surpassing conventional artillery. The Battle of the Bulge, December 1944, cemented the P-47 status as an all-weather fighter bomber. Even freezing fog and snow could not stop it. Equipped with British-developed rocket rails and advanced instruments, P-47s flew 647 sorties on December 23rd alone, claiming over 400 vehicles destroyed. From December 23rd to 27th, the statistics tell the unmistakable story. The Thunderbolt had evolved into an unstoppable instrument of tactical air supremacy. By early 1945, the P-47 Thunderbolt had become an instrument of near-total destruction. Across Europe, confirmed kills tell a story that reads like a ledger of devastation. 201, German tanks destroyed, 1,1030 motor vehicles wiped out, 953 horse-drawn vehicles obliterated, 89 locomotives annihilated, 512 railcars rendered useless, and 47 bridges damaged or leveled. January revealed another extraordinary talent, precision bridge busting with 1,000-pound bombs. The 56th Fighter Group devised techniques that could destroy Rhine bridges previously thought impervious, delivering 8 bombs from a mere 50-foot margin of error in a 60-degree dive precision the heavy bombers, even at high altitude, could only dream of, lucky to come within 1,000 feet of their target. Early 1945 also saw the emergence of the Me-262 jet fighter, a technological marvel with a 100 mph speed advantage over any P-47. The jets seemed untouchable, but the Thunderbolt's evolution as a fighter bomber exposed an Achilles heel. The jets required long concrete runways and consumed fuel at prodigious rates. Their bases became prime targets for the now versatile P-47s. On March 21, 1945, Thunderbolts of the 365th Fighter Group caught JG-7's Me-262's mid-takeoff at Leitheim Airfield. As the jets roared down the runway, unable to maneuver or gain speed, 8 Me-262s were destroyed in 5 minutes, more than the Luftwaffe could replace in an entire week. March also brought Operation Clarion, a systematic assault on Germany's transportation network. P-47s were assigned sectors with orders to annihilate anything that moved or could move. On March 22nd alone, the results were staggering. 89 locomotives destroyed, 1,026 rail cars leveled, 155 motor vehicles eliminated, 17 bridges demolished, and 93 rail cuts executed. The Thunderbolt had become both scalpel and hammer, surgical and devastating in equal measure. The P-47's evolution was the product of relentless innovation. By mid-1944, the P-47 D-25 featured reinforced wings rated for 3,000 pounds of external load, universal bomb shackles compatible with both British and American ordnance, zero-length rocket launchers to reduce drag, improved oil cooling for extended low-altitude operations, paddle blade propellers for superior acceleration, water injection boosting power to 2,800 horsepower, and the K-14 computing gun sight for accurate bombing. Republic Aviation's plants at Farmingdale and Evansville demonstrated industrial brilliance, producing 35 P-47s per day at peak, rolling out 28 major variants and 430 field modification kits, all without halting production for redesign for 48 months, a feat unmatched in fighter manufacturing. Transforming pilots into multi-role combat aviators required a revolution in training. The USAAF mandated 200 flight hours minimum before combat, including 50 practice bombing runs, 20 rocket passes, 100 strafing runs, 40 hours of instrument flying, and 30 hours in formation. In contrast, late-war Luftwaffe pilots went into combat with only 110 hours and no fighter-bomber preparation. American pilots mastered high-altitude escort, medium-altitude combat, low-level navigation, dive bombing, skip and glide bombing, rocket firing, napalm delivery, and strafing switching roles seamlessly as missions demanded. February 1945 saw P-47s first deploy napalm. Using 150-gallon drop tanks filled with jellied gasoline, they could incinerate entire city blocks or forested supply positions. On February 14, 1945, the 302nd Fighter Group unleashed this new terror on a Wehrmacht depot in Reichswald Forest. 8 P-47s, each carrying a napalm tank and a 500-pound bomb, created a firestorm visible from 20 miles away, destroying 3 acres of supplies in minutes. March to May 1945 marked the Thunderbolts' evolutionary peak. The P-47M, capable of 470 mph, could contend with early jets. The P-47N, built for the Pacific, carried a 2,350-mile range with bombs. Yet, it was tactical versatility that revolutionized warfare. P-47 served as forward air controllers, artillery spotters, photo reconnaissance platforms, communication relays, psychological warfare aircraft dropping leaflets, and emergency supply deliverers to encircled units. One aircraft could perform 6 mission types in a single day. The statistics are staggering. 50 and 683 P-47s were built, the most produced American fighter. Farmingdale contributed 9,086, Evansville 6,242, and Curtiss-Wright Buffalo 354. Peak daily production reached 35 aircraft. Unit costs dropped from $105,594 in 1942 to $83,001 in 1945. P-47s flew over 746,000 sorties with 3,499 combat losses and 1,023 non-combat losses, a loss rate of just 0.7% per sortie. The air-to-air kill ratio reached 4.6 to 1. In ordnance alone, they dropped 132,000 tons of bombs, fired 135,000 rockets, and unleashed 119 million .50 caliber rounds. Confirmed destruction in the European theater included 3,716 enemy aircraft in air combat, 302 on the ground, 9,000 locomotives, 86,000 rail cars, 68,000 motor vehicles, 6,000 armored vehicles, and 60,000 horse-drawn vehicles. The P-47 fundamentally redefined military strategy. Pre-war doctrine rigidly separated strategic and tactical air power bombers for strategic targets, fighters for air superiority, attack aircraft for ground support. The Thunderbolt merged these roles, achieving strategic results through tactical application. By April 1945, German forces could no longer move in daylight. Railways, roads, and bridges, the arteries of an army, had been surgically and relentlessly severed by a single aircraft type, reshaping the final months of the war and setting a new standard for aerial warfare. By the spring of 1945, German supply lines had ground to a halt. Reinforcements could not reach the front. Ammunition stockpiles dwindled, and the Wehrmacht's capacity to maneuver collapsed. What had begun as tactical air operations had, through sheer accumulation, achieved strategic effect. Analysis by the Strategic Bombing Survey revealed that fighter-bomber missions primarily carried out by P-47 Thunderbolts had reduced German rail traffic in forward areas by 75% by March 1945. This paralysis of transportation contributed more directly to the collapse of Germany's war effort than the destruction of industrial centers by heavy bombers. The P-47's unprecedented success forced a radical reevaluation of military doctrine. By 1947, the U.S. Air Force's first doctrine manual stated plainly, the artificial distinction between fighter and attack aircraft has been rendered obsolete. All fighters must be capable of ground attack. All attack aircraft must be capable of self-defense. This was a complete reversal of pre-war thinking. The 1935 Army Air Corps manual had insisted, pursuit aviation's sole purpose is achieving air superiority through aerial combat. Diversion to other roles weakens this primary mission. The Thunderbolt demonstrated that flexibility multiplied combat power. A fighter that could only fight was half as valuable as one that could fight and strike the ground with equal efficiency. The P-47's influence extended far beyond the European theater. Its concept became the blueprint for post-war aircraft design around the globe. When the Korean War erupted in 1950, direct descendants such as the F-84 Thunderjet and F-86 Sabre, configured as fighter bombers, dominated tactical air warfare. The multi-role fighter pioneered by the P-47 had become standard doctrine. Republic Aviation's transformation of the P-47 also represented the pinnacle of American industrial ingenuity. Alexander Kartvali, the company's founder, had built the aircraft with extraordinary strength margins. The Army Air Forces requested a 6G capable fighter. Kartvali delivered one rated for 12G. They specified 500-pound bomb capability. He engineered the structure to carry 2,500 pounds. This over-engineering allowed rapid field modifications that transformed the aircraft's capabilities far faster than formal redesigns. By 1945, P-47s leaving the Farmingdale and Evansville plants incorporated hundreds of combat-driven improvements, yet production never ceased. The numbers are staggering. 15.683 aircraft built over 48 months of continuous production, 28 major variants, 430 field modification kits, peak output of 35 aircraft per day from 2 plants operating simultaneously, and a 27% reduction in unit cost despite continuous capability increases. The P-47's fighter-bomber concept shaped every subsequent combat aircraft. Its direct descendants include the F-84 Thunderjet, the A-10 Thunderbolt II, named explicitly to carry the P-47's ground attack mission forward, and the F-105 Thunderchief, a strategic fighter bomber extending the Thunderbolt philosophy. Conceptual inheritors include the F-4 Phantom II, F-16 Fighting Falcon, F-15 E-Strike Eagle, F-A-18 Hornet, and the F-35 Lightning II. All share the core principle Kartvali embodied. Build strong, build adaptable, let operational needs drive capability evolution. The revolutionary training program for P-47 pilots also set lasting standards. Pilots were required to complete a minimum of 200 flight hours before combat, 50 practice bombing runs, 20 rocket passes, 100 strafing runs, 40 hours of instrument flying, and 30 hours of formation flying. These rigorous requirements contrasted sharply with late-war Luftwaffe training, which had declined to just 110 hours. With no fighter bomber instruction, American pilots mastered high-altitude escort, low-level navigation, dive bombing, rocket attacks, napalm delivery, and ground strafing switching seamlessly between roles during a single mission. Luftwaffe veterans, reflecting post-war, consistently identified the P-47 fighter bomber as decisive in Germany's defeat. Gunther Rahl, who flew and evaluated captured P-47s extensively, noted in a 1996 HistoryNet interview the aircraft's comfort, reliability, and versatility. He singled out its engine, free of oil leaks that plagued German designs, as a testament to American engineering. Statistical analysis confirms these assessments. The P-47's combination of firepower, survivability, payload, and adaptability created a combat multiplier unmatched by any contemporary aircraft. The Thunderbolt had not only rewritten the rules of air combat, it had proven that a single aircraft type, executed intelligently, could achieve strategic results previously thought possible only with an entire bomber fleet. It was, in every sense, the aircraft that transformed warfare and the industrial and doctrinal thinking that underpinned it forever. By the final months of the war, the Luftwaffe could field only around 100 operational fighters on any given day, not for lack of aircraft, but because fuel, airfields, and logistical networks had been systematically destroyed by P-47 Thunderbolts. The fighter bomber had accomplished what strategic bombing alone could not: complete paralysis of enemy operations. The P-47's efficiency was extraordinary. Compare the economics. The cost per ton of bombs delivered: B-17 Flying Fortress, $28,000, B-24 Liberator, $24,000, P-47 Thunderbolt, $4,200. Crew losses per 100 tons delivered: B-17, 8.5 aircrew, B-24, 7.2, P-47, 0.9 pilots. Ground support required per ton: B-17, 47 personnel, P-47, just 8. The mathematics were undeniable. P-47s delivered destruction at 15% of the cost and with 10% of the manpower investment of heavy bombers. The transformation of the P-47 from pure fighter to fighter bomber carrying half of B-17's operational bomb load represents more than tactical evolution. It embodies the American genius for pragmatic adaptation. The Luftwaffe never expected such a metamorphosis because it violated their rigid understanding of specialized military equipment. German doctrine prized perfection within narrow roles. The best fighter, the best bomber, the best attack aircraft. American doctrine, shaped by industrial pragmatism, prized versatility and efficiency. The P-47 proved that in modern warfare, flexibility outstrips specialization. When Luftwaffe pilots encountered P-47s over Eindhoven on September 17, 1944, they faced not just an aircraft, but a revolution in military thought. Those heavy, clumsy interceptors they had dismissed in 1943 had become instruments of their destruction, not by excelling in any single role, but through unprecedented adaptability. The P-47's record in the European theater from 1943 to 1945 is among the most remarkable in aviation history. Performance highlights: maximum speed, 433 mph for the P-47D, 470 mph for the P-47M, combat radius, 450 miles with drop tanks, service ceiling 43,000 feet, maximum bomb load, 2,500 pounds. Production excellence: 15,683 aircraft built, peak monthly output 1,050, 28 variants, 430 field modifications, and a 27% reduction in unit cost over the production run. Combat effectiveness: 746,000 sorties flown, 0.7% loss rate per sortie, 4.6 to 1 air-to-air kill ratio, 132,000 tons of bombs dropped, and over 224,000 ground targets destroyed. The story of the Luftwaffe's failure to anticipate the P-47's ability to carry half of B-17's bomb load illuminates a profound truth about military innovation. The Germans, masters of specialized excellence, could not imagine that the Americans would blur the lines between fighter and bomber, producing an aircraft that excelled not through perfection in one role, but through competence in all. The P-47 Thunderbolt's evolution from interceptor to fighter bomber did more than surprise the Luftwaffe. It transformed air warfare. Every modern combat aircraft flying today carries lessons learned from the Thunderbolt's versatility. The heavy fighter that could not outturn a Messerschmitt became the aircraft that helped turn the tide of World War II. In the end, the 7-ton fighter dismissed as too heavy to matter, became an instrument of devastation, not through superior performance in any single metric, but through superior adaptability. The P-47 proved that in modern warfare, victory favors those who adapt fastest to changing realities. The Luftwaffe never expected Thunderbolts to carry half a B-17's bomb load because such capability violated their core assumptions about air combat. That failure of imagination cost them air superiority, mobility, and ultimately the war. The transformation of the P-47 from fighter to fighter bomber stands as history's clearest example of how tactical innovation can achieve strategic revolution, and how failing to recognize that revolution can doom even the most professional military force to catastrophic defeat.